So I'm going to back up a little bit. Okay, so we're going to determine how to find an inverse function. Inverses undo each other, and they're not all as obvious as f of x and g of x that I have here. So when we are finding an inverse function, the first thing that we want to do is rewrite the function with y instead of f of x. Now, when we have a function in the inverse, we said that the domain of the function is the range of the inverse, and the range of the function is the domain. In other words, x and y switch places. So I'm going to let x and y switch places. So I'm going to change this function, and it's going to become x equals 5 minus 3y over 2. After the x and the y switch places, then we're going to solve for y. So in the function that I'm finding the inverse, I'm going to multiply both sides by 2. We get 2x equals 5 minus 3y. Subtract 5 from both sides. And then we will divide by negative 3. Okay, so we can leave it like that, or I could rewrite it as 5 minus 2x over 3. And that is my y, which is the inverse function. So we're going to then replace y with the inverse. And then we can verify.
Wait, so how did you change it from like 2x minus 5 over negative 3 to 5 minus 2x
Okay,
over 3?
good question. If we take this out here and then distribute it, we're going to get a negative 2x plus 5.
Oh.
You can leave it with the negative on bottom, but you usually won't see a function that way. All right, and the final step is to verify. So if this is the, let me move this so I can see what the original function was. If this is f of x, I'm going to find f of g of x, or the inverse. I'll go ahead, since we called it an inverse, we'll use inverse notation. So in f of x, I'm going to have 5 minus 3 times 5 minus 2x over 3. And that's all over 2. That looks kind of bad, but if we simplify, what happens to this 3 and this 3?
Cancel.
They cancel. So we have 5 minus 5 plus 2x over 2. Well, these cancel.
Why is plus 2x?
Because a negative times a negative is a positive.
So you just
distribute.
cross out the 3, not the negative.
Mm-hmm. And then so we have 2x over 2, which is x. So we verified it. That is the inverse function. Okay, so let's do another one. Clean my screen.
So can they like hear me when you play? Oh, okay.
I was wondering,
It's like right now.
what does the future look like?
All right, here's our function. Let's think about this. What's the domain of this function?
All real numbers.
Domain is all real numbers.
Sorry.
That's the only
Can we tell what the range is?
Yeah.
What is the range?
One.
The y values, possible y values.
Zero is an infinity to negative infinity.
Okay, the range is also all real numbers, negative infinity to infinity. We always go from smaller to larger. Okay, because this is the parent function is what kind of function? What's the parent function? A cubic function, okay? And we've scooted it up one. That plus one means we shift it up one, and 3 means we stretch it. So, domains negative infinity to positive infinity, ranges negative infinity to positive infinity. I want to find the inverse. So the inverse, we're going to replace our f of x with y. And then switch x and y. Now we want to solve it for y. So we're going to subtract 1. Divide by 3. Just algebra skills from this point. How am I going to change that from y cubed to y?
Third root.
Take the cube root. And the cube root of y cubed is simply y. So if we did it correctly, this is our inverse function. How can I tell, Caden, if I did it correctly?
You gotta plug the inverse into the regular.
Okay, we can plug the inverse into the original function and make sure we get x. So if we do that, f of the composition of the function with its inverse, we're going to have 3 times the cube root of x minus 1 over 3 cubed plus 1. Now, what is the cubed root of x minus 1 cubed cubed? When I cube a cube root, it just gets rid of the root. Okay? Notice the 3's cancel. And we have x minus 1 plus 1, which is x. All right. So we said that the domain of the original function was negative infinity to positive infinity. Oops. So that is the range of the inverse function. And we said that the range of the original was negative infinity to positive infinity, so that's the domain of the inverse function. Remember, x and y switch places, which means the domain and the range switch places as well.
Makes sense.
All right, let's do one more.
You know how you can just like square and make it go away? Should we do that? Maybe.
It's cold over and looking at you like you're yeah, the door's at the back.
And that's I do too.
All right, here's your function. F of x equals the square root of 2x minus 3. What is the domain of this function?
All.
Nope, it's under square root. You be careful now.
Careful now.
It can't.
Keeping you on track.
Woo!
What would it be, Sean?
Wow.
It'll be 0 to infinity.
0 to infinity? What if I plug in a 0? What am I going to get?
Square root of negative 3.
Can we have square root of negative 3?
No, you can
No,
have.
you can't.
So what's it going to be, Maddie?
Come
What
on.
has to be, what do we know about what's under the radical? What does it have to be?
It can't be 0.
It can't, yeah, it can.
Uh-oh. Can't be on negative.
It can't be a negative.
It can't be a negative, so what can it be?
It can be a positive number.
It can be,
That is the exactly what we're looking for.
Robert?
Say greater than 1.
No.
But it'd be a negative.
Chill.
2x minus 3 has to be,
There's no domain.
David?
Has to be greater or equal to 3.
No, greater than or equal to 0.
But if it's
But
one.
What?
it can't be 0 though.
Yeah, it can. The square root of 0 is 0.
Like, but
In this code,
Okay.
if 1 is negative 1. Like,
What?
if
Okay,
X is
so it
1,
has to
it's
be,
1.
I haven't solved it yet. 2x has to be greater than or equal to 3. Or x has to be greater than or equal to,
How
3
many
halves.
domains are there?
do what?
How many domains are there?
Infinite.
Well,
it
could change with every function. For this function, the domain is x is greater than or equal to 3 halves. So we could say from 3 halves to infinity. Okay, whenever you have a square root, you set whatever's under the square root greater than or equal to 0.
Every time.
Every time.
Every time.
Every time.
All right. So that's the domain of that function. What about the range? Any idea here?
Nope.
I got no idea.
Okay, no idea. So let's find the inverse and see if we can find the domain of the inverse.
Okay.
Uh-oh.
All right,
Do we
so-
have to know the domain and range?
The only
Because
part
just
I know
gotta
how to do
sleep.
is make f of x y.
Okay, well, you did that. Then what do we do? What's the second step?
We need to get rid of the square root sign.
Not yet. What's the second step? Who?
It's
Yes.
the second
Push
step.
correct.
Liz, what's the second step?
Let-
Switch x and y. Domain and range change places. Switch x and y. Now we solve for y. How do I do that?
Multiply each side by 2.
By 2?
Whoa,
Yeah, because you have a square root.
wrong.
What
Raise
happened?
it to the second power.
Well, that's what
Square both sides.
Sorry.
It's okay, maybe once
Dang it. I always get that confused.
All right.
It's what we're here for, to learn.
And in this case, we're going to solve. So we have x squared plus 3 equals 2y. And y equals,
X squared plus 3 over 2.
and that is our inverse function. Now that's not really going to help us this time on our range. Let's think about the graph of a square root function. You know what the graph of a square root function looks like.
You don't do it?
Wait,
What does f of x equals the square root of x look like?
It's the half.
It's the little thingy when it goes up.
What's the range?
0
0
to
to
infinity.
infinity.
So this range is 0 to infinity.
Oh.
All right. What is the domain of the inverse then?
Negative infinity probably.
To infinity.
It's 0 to infinity.
Oh, yeah, because there's square root.
And what's the range?
3 halves to infinity.
3 halves to infinity.
Okay.
Wow. If you don't follow along, you can get really lost if you just look up there.
Well, yeah.
Yeah.
Not that I was doing that, but just what, Costanza?
All right. If we want to check this,
It's verification time.
We should get Owen Wilson to come to our ceremony.
Should give our graduate.
Sorry.
I'm still shooting for George Bush, but. I get it now.
you think you got some pull there?
Well, we already sent him one letter and he said that he has a busy schedule, but he just doesn't.
You
know
really
who-
did?
Yeah, he just doesn't know who we're talking, who he's talking to, but, like, he hasn't seen Nicholas Felix and I's face yet. Once he does that, he'll be here.
Once he does that, he's just gonna say no even more.
He'll
Where
run
are you
for the
gonna find
hills.
ranch? No, did you know that you can't,
It's in the Highlands, isn't it?
no, his ranch is a no-fly zone, like, I was looking on my
Imagine.
I was looking on my brother's radar, like, for the helicopter, and you can't, like, they can't fly within, like, a certain radius of it.
Okay,
I wish I was that important.
Coach?
Okay.
so let's look at this. Do you see what I've
You
done?
guys were talking about a coach. and I'm
What did I just do here?
Coach Gibson.
Maddie?
Shh.
Okay, we did the composition.
Oh, no, I don't like to look at
All right, now notice
Whoa.
the choose cancel.
Yes, thank goodness.
If you've done it correctly, things will always cancel out real nicely.
That's what
Ah,
I like to
perfect.
hear. And then.
So now we have the square root, Robert,
X squared. Ooh.
You X squared.
plus 3 minus 3, which equals the square root of x squared,
Yay.
which equals
X.
x.
Oh my gosh. This
Without
is
the tree
okay.
figure.
I'm getting.
So
it.
did we do it correctly?
Yes.
We did.
I'm doing it. I'm doing it.
All right. Your assignment,
Oh.
Hey, can you give me a sheet of paper?
Yeah, I got
It
you,
was. Fam. We called you Fam.
Far from it. Yes, okay.
Beggars can't be choosers.
I was just about to say that.
Don't bite the hand that feeds you. What? I don't know.
Okay,
If choices were horses, beggars would ride.
What? No.
Out.
That's my grandma's quote.